As one of the most important terrestrial ecosystems in terms of climate change adaptation and mitigation, we're going to look at how climate change and forest ecosystems are related. Let us look at the functions and services of forest ecosystem first. In terms of function, forests are a stabilizing force for the climate. They regulate ecosystems, protect biodiversity, and play an integral part in the carbon cycle, both storing and releasing carbon in a dynamic process of growth, decay, disturbance, and renewal. When it comes to service, they support livelihoods and supply goods and services to people in the form of food, fuel, medicine, employment, and income through wood and non-timber forest products. Then, what is the role of forest in climate change? In fact, forests act as both a cause and a solution for greenhouse gas emissions. When we talk about the cause, deforestation and forest degradation is the cause of as much as 5 to 10 gigaton carbon dioxide global emissions. Regarding the solution, approximately 2.6 gigaton carbon dioxide, which is one-third of the CO2 released from the burning of fossil fuels, is absorbed by forests every year. Taking into account these roles of forests in climate change, in order to maximize the climate change benefits, it is dispensable to keep more forest landscapes intact, manage them more sustainably, and restore more of those landscapes which we have lost. Now, how are forest ecosystems impacted by climate change? Forest ecosystems are threatened mainly by precipitation and temperature patterns change. However, forest ecosystems are not only being affected by climate change impacts, but also by non-climate threats such as land use, pollution, and overexploitation. Climate change impacts humans directly and can also affect humans and biodiversity indirectly through its influence on forest landscape. The local community that is reliant on forest and biodiversity is a typical example that suffers from indirect impacts of climate change. Forests' major changes due to the impact of climate change and non-climate threats include increase in forest fires due to droughts, changes in species composition, productivity, and biodiversity, which will lead to the spread of invasive species and reduced production of wood and wood products that leads to losses in income for forest communities and the timber industry. And also the rise in incidence of pest outbreaks and decrease in the availability of water in forested watersheds. As explained, these changes are intimately related to the quality of ecosystem services which support local communities. So it's important to maintain a healthy forest ecosystems through sustainable forest management in order to reduce vulnerabilities of forests themselves and of the human populations dependent on them. Then, what type of mitigation and adaptation are there to address the climate change impacts in the forest sector? As explained earlier, forests act as both a cause and a solution for greenhouse gas emissions. Mitigation strategies in the forest sector that address the cause and enhance the solution can be grouped into reducing emissions from deforestation and forest degradation, such as REDD+, enhancing forest carbon sinks, and product substitution, such as the use of wood instead of fossil fuel for energy. When it comes to adaptation, there are two concepts: forests for adaptation and adaptation for forests. Forest for adaptation is to reduce the vulnerability of the forest-dependent populations, while adaptation for forests is to decrease the vulnerability of forests themselves. To implement ecosystem-based adaptation or EBA options, adaptation for forests is needed to ensure the role of forests for adaptation. Involvement of local communities in mitigation efforts through forest restoration will result in enhancing the community's adaptive capacity to climate change. So the linkage between mitigation and adaptation is highlighted in the forest sector. EBA underlines the linkage between mitigation and adaptation through the provision of ecosystem services. That is to say, mitigation measures such as afforestation, reforestation, and sustainable forest management can provide ecosystem services that will help communities to adapt to climate change. Typical ecosystem-based adaptation and mitigation options in the forest interface include protection of natural forests, native tree afforestation and reforestation, and agroforestry. The first option is protection of natural forests through establishment of protected areas. The reason why forest protected areas are important in the adaptation to climate change is because it supports species to adapt to changing climate patterns and sudden climate events, protect people from sudden climatic events and reduce vulnerability to weather-induced problems, and supports economies to adapt to climate change indirectly. To put it simply, establishment of protected areas has two phases: design and management. When it comes to designing, it is necessary to plan protected area network without barriers and obstacles between protected areas to help species that are present in few fragmented patches of habitat to adapt to climate change. Buffers, connections, and corridors have the function to ensure protected area network. It should be also noted that size, shape, and altitudinal gradients contribute to a protected area's resilience to climate change and to species' freedom of movement. Regarding management of protected areas, in order to ensure adaptation to climate change, management may include restoration, focusing on resilient habitats, managing specifically for anticipated threats such as fire and pests, and addressing other threats which can be exacerbated by climate change. The next options are afforestation and reforestation. Both of them are types of tree planting, but have slightly different definitions. Afforestation is to convert long-time non-forested land into forest. This long time is about 50 years, according to UNFCCC. On the other hand, reforestation needs to convert recently non-forested land into forest. In both cases, it is desirable to plant native, climate-resilient, and multi-use species that benefit local communities, for example, by providing non-timber forest products, shade, and windbreaks. It is also important to ensure extension and improvement of tree nursery to provide a steady supply of plants for afforestation and reforestation. Climate change impacts targeted by afforestation and reforestation are landslides and slope failure resulting from increasingly frequent and extreme rainfall. Now, let us look at the benefits and co-benefits of afforestation and reforestation in addressing climate change. Stabilize slopes and prevents landslides, mud flows, and debris flows, and maintain other ecosystem services and local benefits as adaptation benefits, and promote carbon sequestration, which is a mitigation benefit. When you integrate afforestation and reforestation in a project for those purposes, examples of element of outcome indicators include frequency and severity of landslides and measures of damage from slope failure. Typical success and limiting factors include land ownership, that is related to rights and access to forests, and transferring ownership of larger areas of common forest to local communities, and the associated income based on improved carbon storage. Other factors include social acceptability of afforestation by the community not having conflict with agricultural goals, and landholders' skills, knowledge, and experience relevant for afforestation and reforestation. In terms of cost and benefit, in general, it's been pointed out that there are financial barriers to adaptation. However, if we adopt afforestation and reforestation as adaptation practice and integrate some mitigation objectives, you may be able to overcome these financial barriers to adaptation because you may be able to benefit from carbon funding such as CDM, REDD+, voluntary carbon markets, and so on. Afforestation and reforestation can also help in increasing local mitigation co-benefits and the local capacity to cope with climate change by ensuring social, economic, and environmental improvements, contributing to the increase in productivity and resilience of land and provide additional income generation, and contributing to guarantee ecosystem services by reducing vulnerability to climate change, again highlighting the importance of forests that help in regulating natural resources, controlling hydrological processes and land degradation, maintaining species biodiversity, and so on. This is an example of a afforestation and reforestation project in the Pacific. The project name is Whole of Island Reforestation and Agroforestry Program in Taveuni, Fiji. In fact, this is one of the EBA demonstration projects of PBAC. Interventions listed in the island-wide EBA master plan included establishment of nurseries and reforestation, agroforestry, coral reef improvement, and mangrove planting. In terms of nurseries and reforestation, a central native tree nursery was constructed by the project and handed over to the Ministry of Forest. And 4,500 native trees were planted, and committees under the provincial councils were established to help drive conservation and natural resource management. The third EBA option for forest is agroforestry. Agroforestry is a dynamic, ecologically based natural resource management system that diversifies and sustains production for increased social, economic, and environmental benefits for land users at all levels through the integration of trees on farms and in the agricultural landscape. In general, there are three main types of agroforestry systems that are agri-silvicultural, silvopastoral, and agro-silvopastoral systems. Agri-silvicultural systems are a combination of crops and trees, such as alley cropping or home gardens. And silvopastoral systems combine forestry and grazing of domesticated animals on pastures, rangelands, or on farms. And agro-silvopastoral systems integrate the three elements, namely trees, animals, and crops, and are illustrated by home gardens involving animals as well as scattered trees on croplands used for grazing after harvest. Originally, Agroforestry had been practiced in the Pacific Islands for thousands of years traditionally. However, starting in the colonial era and intensifying in the 20th century, Pacific Islands agroforestry systems were rapidly displaced in favor of monocultures. Agroforestry has received attention in global climate discussions recently for its carbon sink potential, playing a defining role in offsetting greenhouse gases and providing sustainable livelihoods. Agroforestry has also been discussed in the context of localizing sustainable development goals and achieving biodiversity targets. Now, we're going to look at the benefits and the co-benefits of agroforestry in addressing climate change. As adaptation benefits, agroforestry makes more efficient use of natural resources such as soil, sand, and water, provide a more favorable environment for sustained production, such as shade, wind protection, soil conservation, nutrient cycling, and habitat diversity. Be more profitable, reduced expenses, diversified products, continuous flow of products, greater self-reliance, improve the environment, such as reduced pressure on natural forests, species diversity, resource conservation, and decreased pollution, and be culturally compatible, such as locally based, adaptable, and acceptable. As mitigation benefit, agroforestry promotes carbon sequestration. Examples of outcome indicators of agroforestry include measures of soil quality and erosion, and agricultural yields and income, which is sometimes divided into home consumption and market selling. Then, what type of tree species are appropriate for agroforestry in the Pacific countries? Examples of selection criteria are trees that provide timber, fuels, handicrafts, food, fruits, and nuts, soil nutrition and protection, forage and fodder, medicine and cultural values, and trees that contribute to environmental protection, biological conservation, and carbon sequestration. Agroforestry is surely a good option for climate change adaptation, but it also has issues and challenges. Unclear status of land and tree resources, unsecured, ambiguous tenure results in confusion about land delineation and rights, which may discourage people from introducing or continuing agroforest practices, and limited awareness of the advantages of agroforestry. Overdependence on conventional agricultural methods and inadequate knowledge of sustainable approaches restrict the interest of policymakers in agroforestry development, and delayed return on investment. The break-even point for some agroforestry systems may occur only after a number of years. And other issues and challenges include underdeveloped markets, lack of coordination between sectors, emphasis on commercial agriculture, and adverse regulations. This is an example of agroforestry project in the Pacific. The project name is Strengthening Capacity for Household Integrated Agroforestry and Food Crops Production in Nauru. This project was funded by FAO and started in 2014 and ended in 2016. The total funding was 259,000 US dollars, and the implementation agency with the Ministry of Commerce, Industry and the Environment. This project aimed at facilitating household engagement in agroforestry and encouraging the production of selected fruit trees, root crops, vegetables, and valued forest species. And the key outcomes included improved food and nutrition security through increased household production and utilization of fruits, vegetables, food crops, and multipurpose tree species, adequately trained staff and locals in agroforestry, and crops production for improved household nutrition, improved soil fertility, and finally reduced imports and strengthening the domestic market to offer a broad range of local fruits, food crops, and handicraft for sale.